Okay, so possible zeros. Okay, so there's something called the rational zero test. You may have seen this in Algebra 2. I don't remember if we did, because I did teach Brave Algebra 2 last year. I don't remember if we covered it, but just so you know what P and Q represent. P represents the factors of the last term. Q represents the factors of the first coefficient, or the leading coefficient. It's a better way of thinking about it. And what you're going to do is, once you list those factors for P and Q, again, P is the factors of the constant, Q's are the factors of the leading coefficient. The ratio of those factors are the possible x-intercepts you can get for the equation. For example, you have 3x cubed plus x squared minus 16x minus 35. So it's asked for possible rational zeros. What they're asking for are possible x-intercepts. That's what they're asking for. Possible x-intercepts. So P is simply all the factors of negative 35. What are the factors of negative 35? You can start with 1 in itself, right? And by the way, we have to put plus or minus because numbers can be divided by 1 or negative 1, right? Or the number itself can be divided by itself or the negative of itself, right? So those are possible factors of negative 35. Are there more? 7, 5, and that's it. We exhausted it all, right? Because sometimes you could do a prime factor tree if that helps, if you're ever stuck. I mean, I won't give you ridiculous numbers. I won't give you like 248 or something like that. But if you think about 35 as a prime factor tree, you don't have to write this down. You guys remember that? 5 and 7 and 1 itself. So that's it. That's all we got. Now, what about Q? Q represents all the factors of the leading coefficient. What's my leading coefficient here? So plus minus 1, plus minus 3. So when you do P over Q, you're simply dividing all the factors of the constant with all the factors of the leading coefficient. So it's going to be all this divided by 1. And anything divided by 1 is what? Itself. Yeah, totally, 100%, right? And all those numbers for P divided by what else? Exactly. Thank you, Timmy. So you got it. Perfect. Good. So what this means...
What is Q again?
All the factors of the leading coefficient. Yeah, A sub n, which means the leading coefficient. Whatever number's out in front for the highest exponent. And 35 thirds. Now, how many possibilities is that? I mean, if you do a quick count. I did put that. Right? So how many is it all together? Is it 8 or is it more than 8? 16. There's 16 possibilities. So it means that there's 16 possible x-intercepts for this. Now, of course, it's degree 3. So we know that we only have at most 3. But here's where it gets kind of murky. So this could be imaginary, right? We're going to talk about imaginary zeros and more about that some other day. So let's go to the imaginary. That's a possibility. Also, this would be really cool. Is that I could give you a problem, tell you ideas, and tell you to test these out, see which ones work. It's possible none of these work. That's also a possibility because maybe the x-intercept is wacky rabbit. Like for example, roots 5. Like that's a wacky rabbit, right? It's like there's no rhyme or reason to it. It's like 2 point something. That's not a rational number. Do you guys remember what rational numbers are? I know it's kind of been a while since we talked about it. Does anyone have a definition of what a rational number is? Think about the word rational or ratio. It's a play on words, actually. Ratio. What is a ratio in general? If you're like given a ratio, like for example, the boy to girl ratio here is I should know this actually, 9 to 3. So what does that mean? What is a ratio as a number? Or the girl to boy ratio is 3 to 9. How do you reduce 3 to 9? What would that be when you reduce it? What is that called? That ratio. Thank you, Jamie. Yes, fraction. That's what I was looking for. Good. I know I wasn't very clear about my question. It's a fraction, totally. And it's a fraction of what? Of 2 integers. It's a fraction of 2 integers. That's what a rational number is. It's like a ratio. A fraction or ratio of two integers. So like, for example, boys and girls in here, it's 3 and 9, right? Or 1 to 3. Or if I did it from boys to girls, it'd be 9 to 3 or 3 to 1. By the way, any whole number, can you make any whole number a fraction? Yeah. What's in the bottom of a whole number if you made it a fraction? 1. So any whole number, any integer is also a rational number. But wacky numbers like 0.3 repeating or 0.5 that has a turn in decimal, those are rational numbers too. So that's what's happening. These are rational numbers. But sometimes an x-intercept might be wacky like this, like root 5 or like root 6, something like that. So you have to be mindful about that. So that's why this is just a possibility. It's not going to work all the time. How do you know if this works? You do what we did in the previous section. What we did in the previous section, we put it into synthetic division to see if it got 0 as a remainder. That's how you would do it. It's a pain in the ass because you have to like test all these out. I'm not going to do that to you guys because that's just dumb. It doesn't make sense for me to have you on a test. Oh, I got to test all 16 of these, see which one of these work. No, I'll give you one of them, and then you have to break down the polynomial afterwards. That's what, or I might just give you a graphic calculus. Hey, graph this. Show me where this touches on the x-axis. Okay, cool. Then you could test that out, break down the polynomial, and then get the other x-intercepts. We'll do an example of that in just a little bit. By the way, did anyone do the SAT on Saturday? The digital version? I know there's a lot of seniors here too. No? Okay. I was curious. They have Desmos now built in. Unfortunately, we don't do Desmos on our test. I think we got to figure out a way to do that because the graphic calculus are becoming obsolete. But anyway, let's try this again just so you get the hang of it. So now I'm going to go a little bit faster. P over Q. So what's my, now careful here. What is my leading coefficient? And don't say 1. 4. Thank you, Jack. Yes. This is the leading coefficient because you have x5. So those are all the possibilities here for Q. And what's my constant? The one that does not have x. 16, there we go. By the way, if you don't see a constant, that means that every term has x. Factor it out, and then you'll get a constant. Factors of 16 are easy. You just get this, right? And you divide all those by 1, divide all those by 2, and divide all those by 4. Now, here's where it gets kind of interesting. And there's a huge amount of redundancy. First, I'll divide all those by 1, right? So you get what you get, right? It's the same thing, not a big deal. Now, here's the deal. I'm actually done. Even though I didn't divide by 2 or 4. Why did I not bother to divide by 2 or 4? Well, actually, no, I'm not done. I lied. There's one more. But Jamie, I'll get to your. I think you got it. There's also plus minus 1/2. My bad. Okay, now I'm done. Okay, Jamie, go ahead. What were you gonna say? Exactly. You can say the answer. Thank you. Exactly. If I do plus minus 2 or plus minus 2, that's still plus minus 1. Plus minus 4, plus minus 2, plus minus 8, plus minus 2, plus minus 6, and plus minus 2. It's all the same thing, just half. The other ones are even numbers. And likewise, if I divide these by 4, 1/4. Darn it. I'm rushing myself here. It's also plus minus 1/4. My apologies. Okay, now I do think I'm done. Because plus minus 2/4 is repeated as plus minus 1/2. Plus minus 4 over plus minus 4 is plus minus 1. Plus minus 8 plus minus 4 is plus minus 2. Plus minus 16 over plus minus 4, I know I'm talking fast, is plus minus 4. So yeah, there you go. So sometimes you don't have to write all these out because they're going to be repeated. I mean, you don't always have to divide each of the numbers up top by each of the ones down below if you see some repetition happening. In this case, there are a total of 14 possibilities, it looks like. So yeah. And I did actually check these out. None of these actually work. These are both very wacky polynomials, but we're not going to do that. Let's talk about example 3. So now example 3, here's what I'd want you to do. So for your homework, use a graphic calculator. I'm going to do both graphic calculator and Desmos. You can use Desmos in your homework too, but you're going to need to be comfortable doing this in the calculator because for now, that's how we do our tests. We just do a graphic calculator. So let me pull up the graphic calculator. Here we go. So 2x raised to the third power plus x squared minus 16x minus 15. Usually when I graph, I'll go to zoom and select option 6 just to reset the window because it goes from -10 to 10 for x, -10 to 10 for y. So it's kind of a good window. Now, just taking a look at it, where do you think it's touching the x-axis? Like, well, there should be one place that looks pretty obvious. Where do you think it's touching the x-axis? Probably -1. Where else do you think? No, 3, probably 3 also. And another one looks like in between -2 and -3. But I'll probably, well, here's the thing. Let's do a quick sketch off the side here. And definitely looks like it's touching at 3. So I'm going to do synthetic division with 3. And I should get 0 as my remainder. Now, the possible rational zeros, again, I should do this anyway. Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, over plus or minus 1, and plus or minus 2. If you were to actually work it out, you get plus or minus 1, plus or minus 3, plus or minus 5. So I know it's a pain, but let's not get lazy. Plus or minus half, plus or minus 3 halves, plus or minus 5 halves, plus or minus 15 halves. Do we see 3 as one of the possibilities here? Yeah. Do I see that one as one of the possibilities? Yeah. And wherever we saw something between -2 and -3, let's probably do the plus minus 5 halves. So this is nice that we're seeing some confirmation here. The graph is confirming this algebraic technique. So it's actually more of a miracle. You list the factors of the constant, list the factors of the main coefficient, taking the ratio, right, because they're rational numbers, and you're seeing the graph itself. Yeah, I do see crossing 30. Yeah, I do see crossing 31. These possibilities are becoming reality, right? That's good. That's a good thing. But what if some of the x-intercepts were really funky, like radicals? Or what if the graph did this? Because it's degree 3, I expect 3 zeros, but some could be complex. They have imaginary zeros, and then they would not touch the x-axis. We got to still figure those out. That's going to happen too. So at the very least, graph, just to find one of them. And by the way, I mean, Desmos is going to be so much easier, right? Desmos. Y equals 2x cubed. You could do shift 6 to do an exponent plus x squared. Ah, yikes. What the heck did I just do? Minus 16x minus 15. I am butterfingers there. Yeah, you see, that's just easier, you know? But let's just do the synthetic division. So remember what to do. Move the 2 down to multiply, add, multiply, add. Things should cancel out nicely. They should. Yeah, I know. Super exciting stuff, right? Okay. Always felt good, just teasing. I know. Spirit Week just exhausted, guys. All right. And then you can factor this, right? 2x, x, plus 5 and plus 1, I think. X equals -5 halves. X equals -1. The graph confirms that as well. So that's what I'd ask you to do is, I don't like the trial and error aspect of it. When I first taught this, gosh, in spring of 2006, my first year working here, I did make my students do this by trial and error, which I don't know what was wrong with me. Why did I do that? It's crazy. Because, you know, what if like all of a sudden these first 4 or actually first 8 don't work and all of a sudden nice fractions? You're just wasting a lot of time. That's dumb. That's just luck. I don't think that makes sense. You know, we have technology, use technology from 1 to 0, and then use some skills to break it down and get the answers. That's what I want you guys to do. So it's a combination of some technology and some algebra, right? Does that make sense? Okay, let's keep moving. Let's get this done. So we'll go a little more quickly here. So for 4, possible rational zeros, plus or minus 1, plus minus 2, plus minus 4. That's the top. The bottom, plus minus 1, plus minus 2, plus minus 3, plus minus 6. So it's going to be all those divided by 1, which is just is what it is for the top. If you divide by 2, you should get plus minus half. But plus minus 2 over 2, plus minus 2 over 4 over 2, forget it. Plus minus a third. Plus minus 2/3 also. And plus minus 4/3 also. And plus minus 1/6. But I'm not going to bother dividing 2 by 6 or 4 by 6. Same thing. A lot of possibilities. Those are all the possibilities. It looks like it's 12 what? 16 possibilities. But you know what? We're going to use the calculator to figure out where it touches the x-axis. Because again, to take a leap of faith and say, well, what if 1 works? What if negative 1 works? I also need to do this 5 or 6 times. I don't like that. That's just dumb. So I'm going to just go to Desmos because I just feel more comfortable using Desmos. So 6. There we have kind of a template here. There we go. So I can identify one of them, 2 for sure. So graph looks like this. Hold on. There we go. 2 for sure. So let's do it. Drop it, multiply, add, multiply, add, multiply, add. That's the work I want you to show. Factor it. It's a little trial and error, I suppose. I mean, you guys use a diamond box. How do you guys, yeah. I mean, it's up to you how you want to factor. I sometimes just get lazy. That's just me. Okay, I got very lucky. There we go, works. Whatever makes sense for you. I know there's one exponent that's negative, one that's positive. So I get negative 2/3. And I get 1/2. Boom, there you go. Very nice. Right? So those are my zeros. Okay, try this again. Actually, we're not going to do it again. I'm going to show you a better way. So you can do static division. But if you can factor right away, then do so. A little tricky. It's x to the 4 power. It's not x squared. But look at the middle term. The middle term is the square root of the leading term, right? It's kind of like a quadratic. It's 3 terms. You guys have an idea of how to factor it? It's a little funky, but you can factor it as a quadratic. Like a quadratic. What 2 numbers multiply negative 36 and add to negative 5? Multiply negative 36, add up to negative 5. Which 2 numbers? Yeah, negative 9 and 4, right? You guys remember this back in the day? You guys do that kind of stuff. But what are we really doing? We're really doing the first term times the last term and put a middle term down there. So it's actually negative 9x squared and 4x squared. So I'm going to put x squared and x squared here. Because if you FOIL that, would you get back to this? Yeah, that's the whole point of factoring. It's opposite FOIL, right? It's factoring of division, FOIL, and multiplication, the inverse of each other. That does make sense. Can I break this down further? X squared minus 9, what kind of factors are? Difference of 2 squares. I could break that down further, like this. So if you can do that, I think that saves some time. The possible rational zeros, sure, you could write them out, but you know what? I'm not going to do that because I factored. Now let's solve each case. What's the first one?
It can't be plus or minus.
No, because it's positive 4.
Um,
It's going to be imaginary, by the way. So if x equals 3, x equals negative 3. And in this case, what if I solve this one here? What's that going to be? X squared equals negative 4. What does x equal? Plus or minus 2i. The complex number is coming back. And they actually come back with a vengeance. There you go. X equals plus or minus 2i. Make sense? Yep, that's what's happening. So let's keep moving. Complex conjugates theorem. So what this states is that if you have a complex number as a 0, and assuming all, here's the other thing too. You have to assume all coefficients are real. You have to assume all coefficients are real. So then the conjugate, the opposite. So for example, I have 1 plus 2i, then 1 minus 2i is also an x-intercept. So here what you asked to do is you asked to write as a product of linear factors with no fractions. Okay, it's a product of linear factors. So f of x equals x minus something, x minus something, and x minus something. What are my x-intercepts here? So you gotta throw this in here. Oh, just give me about 2 minutes. Yeah. Here and here. So if I do that, what's x minus negative 6? X plus 6. X plus 2. X minus 3/2. But you may want to write like this. X plus 6, x plus 2. And if we multiply this by 2, you get 2x minus 3. Because it's the same thing, right? You still get 3/2. Because the whole point is if you set this equal to 0, you can get those answers up above. So you're right, you're working backwards. You're writing the equation that will provide those answers. You're given the answers. What's the equation it came from? That's what they're asking you. What equation did it come from? Usually I leave the answer like this, because you are writing a function after all. Just say f of x equals that. You could, if you put 0 equals that, I wouldn't fault you for that. But just in general, you should write f of x. And the zeros are when you replace f of x with 0 and solve for x. So we're good? Okay. Okay, last one, then we're done. And then if you guys want to work on homework, you can. You guys still have another class after this? Ugh, sorry. You have a late start though. So, all right. So 3 minus 2i is a solution. So is 3 plus 2i. Okay. And now in this case, you're asked to write as a product. So same thing. But you also have to expand it too, which is a pain in the ass. Let's write as a product first, just to get out of the way. Alex, you put your phone away, please. Thanks. Okay, let's do it. X plus 7. I'm going to put a bracket. And do it like this. So you guys see what I just did, right? X minus this number, x minus this complex number, and x minus this complex number. But you have to check complex number in parentheses, and also put brackets and check even more. So I'm being incredibly OCD with brackets and parentheses, so I don't mess up my foil. Let it aside. We are asked to expand, so we're asked to FOIL. I'm going to do it in the painstaking way, and if you guys just want to kind of copy it, great. But I'm going to show you a better way after I finish, and I think the better way you guys might appreciate more. I am going to do it the painstaking way just because I at least have to do it, so it'll be on the video. I can take a screenshot of it. If you want to write that down, great. But the better way is coming up in about 2 or 3 minutes, and then we're done. So here's what I'm gonna do. X plus 7. I'm gonna distribute the minus as I should. But then I'm gonna do this. I'm gonna regroup, which you totally can do. It's totally legit. I didn't do anything wrong. I totally could do that. Then what you do is you FOIL this. First, outside, inside, last. So you have x minus 3 squared. You have positive 2i times x minus 3. Negative 2i times x minus 3. And negative 4i squared. What happens in the middle expressions? They cancel as they should, because they're different. You deliberately made a difference of 2 squares. We deliberately did that. They should cancel. Those are identical. And if you keep going, that's x squared minus 6x plus 9. And what's I squared? So plus 4, right? X plus 7, x plus 7. And then you got to FOIL that again. Geez, yeah, this gets really, really crazy. So that becomes x plus 7 times x squared minus 6x plus 13. And you keep going. I ran out of space clearly. I trust you guys can do that. X times each of those 3 things and x squared minus 6x plus 13. 7 times each of those 3 things with x squared minus 6x plus 13. Let me show you a better way. So I'm going to clear this. Actually, I'll take a screenshot. Okay. Let me clear this now. Here's what I would do. If you think about it, when you solve equations, right? Like just like I did up here where I factored it, right? And I had the answers at the bottom. Well, that's what this is. These are the answers, right? If I had an equation here, f of x equaling all this junk, what do I eventually get? I eventually get x equals negative 7 and x equals 3 plus or minus 2i, right? Let's work backwards. Where did this x minus 7 come from? Didn't it come from that? Right? Where did this come from? Didn't it come from this? And didn't that come from this? Right? If you squared x minus 3 and squared 2i, you get negative 4. And didn't that come from this? And didn't that come from this? See how seamless that was by working backwards? By working backwards. And now we're not doing that blankly flow. See that? I think that's cool. So now I got to plot back that this thing. Just by working backwards, just thinking like what would be the first steps. That's not first step. Now I got to follow. You can't get away from that. I mean, there is going to be some point, but at least this makes the problem less painstaking. So there we go. And again, I got this. And you FOIL it. So that's x cubed minus 6x squared plus 13x plus 7x squared. Actually, let me stack it. Minus 42x. So final answer should be x cubed plus x squared minus 29x plus 91. Now, how do we know that we did this correctly? Yes, you can plug negative 7, see if it makes sense. You can plug in 3 minus 2i, 3 plus 2i, but there's actually a really cool way in the calculator to do it. Shoot, I don't think this has this app. Darn, hold on. Does anyone have graphic calculator on it? Yeah. Yes, you do. Okay. Unfortunately, I don't have it on my device. Sure, I wish I connected. That's okay. I'll have to find some other time. It'd be too confusing. I need that copy of this, guys. Anyway, that's how it works. We're good. All right, well done. You guys got about 20 minutes if you want to get started on homework. If not, you can just chill and relax. Homework is just this stuff here. Yeah, so it's just 3 pages of problems. So there you go. All right, I'll stop recording.